Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 14 of GCP Zero to Hero series, and in this episode, we will learn how to deploy a multi-microservice architectured application onto a Kubernetes cluster. So for this video, we will use Google Kubernetes engine. In fact, we will use GKE autopilot mode to create a Kubernetes cluster so that Kubernetes management is taken care by Google. We don't have to manage the data plane or the control plane. Everything will be managed by Google itself. I'll show you how to create such clusters. We will use G-Cloud CLI as we progress to the next parts of the video. But first of all, as a DevOps engineer, whenever you are dealing with deployment of an application, you should first know the flow of the application, or you should understand what is the application and how exactly the application works. If required, you should also learn how to run this application locally before putting that on a Kubernetes cluster. Now coming to today's application. So this is an open source application. It is actually open sourced by Docker. The source code is available in the Docker samples repository. I'll also try to put the link in the description. Now, once we understand this application, then we will move ahead to learn how to create Docker files for the various services and also how to create Kubernetes manifests for 5 different services that are involved with this application. Coming to the point, so this application is a basic voting application, right? So when you run this application, by the end of this video, even when we run this on Kubernetes, so you will see an option between or an option to vote between 2 different options. For example, by default, it creates a voting poll between cats and dogs. If you expose this application through Ingress, you can open it to public and people can start voting for it. Maybe 1,000, 10,000, n number of people can vote for it. And this also has a results microservice. As an administrator, once you open this application for polling, you can see the results, how many people voted for cats and how many people voted for dogs. And from one machine or from one setup, people can only give one vote so that the voting is very fair and transparent. But overall, there are 2 major microservices or 2 main microservices. One is the voting microservice, which you can expose through Ingress to the external people or public. They can start voting. Someone can vote for cat, someone can vote for dog. And as an administrator, you can head to the results microservice and you can see what is the opinion poll. You can also change these options. By default, it's cats versus dogs. But if you want, you can change this to Docker and probably change this to Podman or Docker Swarm Kubernetes, whatever you are interested in. But Abhishek, if voting and results are 2 main microservices, why are there other microservices? So it's very simple to understand. So voting, results, but as a lot of people keep voting, I mean, if you open this to public, voting microservice needs to cache that information. It has to store that information to fetch that from memory or RAM. So for that, it uses a caching service, which is Redis. And this information is taken care by worker, and worker stores this information onto a database so that as an administrator, when you look at the results microservice for the results, they are fetched from the database, right? Because if someone caches their vote, unless voting microservice puts that information in a database, there is no way results microservice can get that information, because voting and results, they are not directly communicating with each other. Database acts as a medium. Abhishek, but this architecture could have been simple. Probably we can make voting application directly store the information to database. Of course, that's possible. The main intention of this open source application is not to be architecturally right, but the intention is to provide a demo application with multiple microservices involving caching service, involving a database service, and also involving multiple programming languages so that end users can learn containers and end users can learn Kubernetes. If required, they could have open sourced this application. All the microservices, OTing, results, and worker, they could have been written in a single programming language. But Docker, to make sure everyone are comfortable with containers, so they have set up this demo application, right? So once again, this application might not be architecturally right. Probably this could have been much better as well. But when it comes to a demo application, this application is too good for beginners as well as intermediate learners. Okay, now that we understood what exactly this application does, now let's see how to containerize these services. But before that, we need a Kubernetes cluster. Eventually, our plan is to deploy this application onto a Kubernetes cluster. And you all know it's going to take time. So first of all, let's create a Kubernetes cluster. Then let's go back and see the Docker files as well as Kubernetes manifests. So we will use Cloud Shell. Of course, you can create a virtual machine and you can use that virtual machine as well. But for simplicity, I'll use Cloud Shell. There are two major advantages. One is IAM itself. If you're using Cloud Shell, you don't have to authenticate yourself on a different machine, or you don't have to use a service account. Number two, on Cloud Shell, you have a lot of tools installed out of the box. For example, Docker is installed out of the box. kubectl is installed out of the box. gcloud is installed out of the box. So you don't have to do all of these basic installations. That's why I always prefer Cloud Shell. Perfect. So now, because we want to create a Kubernetes cluster, the first thing that we have to do is to enable container APIs using gcloud. Because the container services and even Kubernetes through GKE is actually part of container API. So make sure you enable it. Okay, so I have enabled it. The next step is to create a Kubernetes cluster. Now there are multiple options. Even in the documentation, I have mentioned these options. For example, you can create a basic Kubernetes cluster without using GKE autopilot mode. You can create maybe a 3-node Kubernetes cluster, or you can go with GKE autopilot mode and create a Kubernetes cluster that is completely managed by Google itself. But if you haven't followed my previous lectures, let's say you don't understand what does GKE autopilot mean, very, very simple. Now, when you create a Kubernetes cluster using GKE, it offers two options. One is you manage the data plane, or you manage the nodes of the Kubernetes cluster, or you allow Google to manage the nodes of the Kubernetes cluster. Now, if Google manages the nodes of the Kubernetes cluster, you will see that Google, it takes care of auto scaling it, basically upscaling and downscaling. If you're not running any pods on this Kubernetes cluster, Google technically keeps the number of nodes to 0. Even you will see this once we create a Kubernetes cluster through GKE autopilot mode. When we have 0 pods running, pods from our side or the user pods, you will see when we do kubectl get nodes, the number of nodes are 0. Not only that, it also takes care of cost into consideration. Again, it's complementing the auto scaling feature. It also makes sure that it selects right nodes according to your workloads. Let's say if you are deploying a machine learning workload, it can spin up an instance with GPU power. Or if you are deploying a basic basic Kubernetes pods, then it will probably use a general purpose instance, or if you are deploying a CPU intensive workload, it can also deploy CPU optimized, memory optimized. So all of that comes out of the box if you go with GKE autopilot mode. If you have heard of EKS auto mode, this is exactly the same thing. Okay, and in today's tutorial, because this is something new and this is something that is hugely promoted by Google as well, we will go with GKE autopilot mode. So for that, we just have to run this command. These commands are also provided in the README file. So after watching this video, if you want to try things from your side or at your side, you can just go to this README file and you can run the steps in the same way. Cool. So GKE container clusters create auto, and name of the Kubernetes cluster, I'll just say demo autopilot cluster within the region US Central 1. Of course, you can keep this region nearest to you, or you can choose any region that you're interested in. Cool. This will take up to 10 to 15 minutes. In the meanwhile, while the Kubernetes cluster is getting created, let's go ahead and understand how to containerize these microservices. What is the first microservice? Architecture diagram will help you understand better. So yeah. So the first microservice is the voting microservice. And you can see here, this is written in Python programming language. So if we go to the GitHub repository, right? And if we go to the code folder, whenever you are dealing with Python applications, requirements.txt is part of that application, because in Python, requirements.txt holds the dependencies. In this case, the framework is Flask, and because the voting application is communicating with Redis, the voting application needs a Redis client, and that's why Redis client is also used as a dependency. Now you don't have to worry about these things. Some of these things comes with your experience. As you containerize multiple applications, you also understand why and how some of these dependencies are mentioned. Okay, so requirements.txt anyways is provided by the developers. Then rest of the application is very simple. There is a app.py file. So this is a Flask application that is running the voting service. And then you have static content and template files, right? So this is a HTML file, and these are the styling, basically the CSS that is used as part of the HTML file. Now, what will you write in the Docker file, right? It's very simple, a very basic microservice. Use Python Slim image as the base image. You can also go for Alpine or you can go for Debian. But the problem is that when you go for such base images, you again have to install Python in it. Then, as a good practice, update the app repositories and make sure you delete this directory so that the Python base image size is light in weight. Then choose a working directory. It can be anything. There is no specific working directory that you have to mention. Instead of user local app, you can also go for /opt. Always it's a good practice to copy the dependencies first and run the dependencies instead of copying the whole source code. The reason is very simple. Docker use multiple layers. Docker also use the build caching. In case you copy the complete source code and then you download the dependencies, the problem is that sometimes there is no changes in the source code, but still Docker tries to copy the source code again and again, which leads to increase in the build time. So whenever you run the Docker build command to reduce the build time, make sure you copy the dependencies first, run the dependencies, and then copy the entire source code. In this case, best practice is used, that is multi-stage Docker build. So this is the first stage where the dependencies are run and this stage has all the build dependencies. Then there is a production stage, right? So you have the production stage here, where as part of the production stage, the complete source code is copied. Once the source code is copied, a particular port is exposed, and the Python application binary is run as part of the CMD. So multi-stage Docker builds concept is used. Similarly, results microservice, right? So results microservice is written in Node.js. So you have package.json file. This is what you need to know as DevOps instance. Like when you are dealing with Python application, you need to know requirements.txt is the file that you have to look at. When you are dealing with NPM or Node.js or JS applications, package.json, Go applications, go.mod, Java applications, pom.xml or Gradle file. Coming to the point, in the package.json, you will find the dependencies that are being used. Okay, in this case, not a lot of dependencies are used, and there is just a basic test script. So writing Docker file becomes very, very simple, because all that this microservice has is just the unit test cases, and within views, it has an app.js file and the index.html file. This has the backend for the application, and this has the front end for the application. Cool. So in the results microservice Docker file, we will use a lightweight Node.js base image, just like how we used a lightweight Python base image. In this case, we will use a lightweight Node.js base image. Then we'll install all the dependencies. You must be realizing most of these commands are same. That's a good point. Writing Docker file becomes simple as you keep writing more and more Docker files. Take a lot of base applications, demo applications, and keep writing Docker files for those applications. Again, a work directory is choose, right? Here, npm install nodeman. This is basically for the development use. You can ignore this. Package.json is copied. Dependencies are installed. Then the complete source code is copied. Particular port is exposed. And finally, application is run, right? So this is what I'm talking about. Always make sure you first copy the dependency file, then you execute the dependencies, only then copy the entire source code, and finally run the application. No matter which programming language you are dealing with, please follow the same steps. A lot of people just copy the dependency file as part of the source code itself. It's also fine, but it will increase your build time. Okay, now we learned about voting, results. Let's take a look at worker microservice as well. This is a .NET application. So if you go to worker, because it's a .NET application, it looks slightly different. So you have program.cs file and you have worker.csproj. This has all the metadata information of your application, and the other file has the complete code related to your microservice. Technically, there is no user interface. You might be wondering, Abhishek, for worker microservice, why there is no backend and frontend? Because for other two microservices, there was backend and frontend, because only the voting microservice and result microservice are user facing. This is used by administrators. So results microservice need a user interface. This is used by end users. So that's why this needs a user interface as well. But for worker microservice, it's just taking the information from Redis and pushing it to database. So that's why there is only backend. When there is only backend, writing Docker file even becomes much simple. So first of all, choose .NET base image that is provided by Microsoft. Then these are the arguments for build targets. Like if you want to run it on Windows, if you want to run it on Linux system, it's okay even if you skip, at least for this particular video. Then copy the csproj file, run the .NET command to get the dependencies. And once you have the dependencies, copy the entire source code and publish the .NET application. So these are three microservices, and Dockerify is related to these three microservices. But Abhishek, what about Redis and DB? You don't have to containerize them because you are just using the Redis container image and you will be using the database container image. These are your applications, so you have to build them from source. But even in real time, when you use Redis or when you use DB, you will not be building them. You will just utilize the latest container images of Redis as well as DB. Okay, so we just have to write 3 container files or 3 Docker files, and we are good with understanding those Docker files. To ensure the project is working fine locally, before we put this project onto a Kubernetes cluster, to ensure these Docker files are good, we need to check it locally. For that, we will use a Docker Compose file. If you want, you can run all of those containers individually as well. But when you are dealing with multiple microservices or when you are dealing with multiple containers, it's a good practice to write Docker Compose file. So Docker Compose file is already available within this repository. We will use the Docker Compose file to check the application is working on local machine. In the meanwhile, let's see if our Kubernetes cluster is ready. Cool. So we have the Kubernetes cluster, and if I just do kubectl get nodes, you will not see any nodes on this cluster. That is because we are using GKE autopilot mode, and in autopilot mode, node management is done by Google engine itself. Only when you deploy your first pod, then you will see a node is created for you. I'll show you a sample. I'll just create kubectl create deployment. So I'll just create a Nginx dummy pod. But there is a catch here. For the first time when you create a pod, it will take time. Usually for Nginx deployment, let's say if it takes 45 seconds. In this case, it might go up to 2 minutes as well, because for some time, you will see the pod in pending state. Right now, the pod is pending state because GKE just identified a pod is created. So it takes the decision to create a node, the autopilot mode. And once it creates the node, only then this pod moves to the running state. But this is a one-time thing. Once the pod is created, from next time, the pods usually run at the same pace. Only for the first time with GKE autopilot mode, you will see this timing issue. Right? I think it's almost a minute. Still, the Nginx pod is in the running state. Sorry, pending state. Okay. So let's try it again. It's still in the pending state. After 1 minute, almost after 100 seconds, it moved to container creating state. And yeah, after 2 minutes, it's still in the container creating state. Perfect. Finally, we have the Nginx pod running. And at this point, if I try kubectl get nodes, you will see a node is created. You cannot SSH to this node. You can see the node, you can describe the node, but because this is managed by GKE autopilot, you cannot SSH to it. It's almost like serverless functionality. Okay, great. So we were talking about running the application locally and testing it. So let's first clone this repository. Git clone, Docker samples, example voting application. You can find the link in the GitHub repository as well. If you go to the Day-14 folder of our GCP 0 to Hero, you will find the repository of the source code of the repository. So the link is here. I'll just copy the link. Perfect. We have the code. Now let's run Docker Compose up. So this will start all the containers. For the first time, it takes time. Cool. So we have all the containers running. So Docker Compose started all the containers and they're also connected. We can see this here. Application is running on this particular port. So typically, this application runs on port 8080 that is mentioned in the documentation. Once you run Docker Compose up, you will see voting application is served on port 8080 and results application is served on port 8081. In real time, you can get this information from developer, or if you can read the source code, you can also understand on which ports is the application running. Okay, so let's try it out. We will use web preview. Cloud Shell has a web preview and preview on port 8080. 8080 is the default port, and in this case, voting service is running on port 8080. Let's first check that. Cool. Cats versus dogs and results microservice is running on port 8081. So I'll just do 8081 and also run it. Okay, so we have the voting microservice and we have the results microservice as well. What does the results microservice say? No votes yet. That's why it's 50-50%. Now I'll just vote for cats first. Okay, my vote is casted. I'll go to the results microservice and I can see there is one vote overall and 100% is for the cats. If I just change my vote to dogs, it should reflect immediately and dogs is now 100%. Same one vote is casted. As I told you, from one machine, only one vote is considered. This is very fast because the Redis layer is being used and instantly data is pushed to the database. Cool. So I'll just stop both of them and I'll also stop Docker Compose on my local machine. I'm using Cloud Shell. Let me also do Docker Compose down to make sure all the containers are removed. Perfect. So we tested it locally. Once we test it locally, the next step is to run them on a Kubernetes cluster. We already verified Kubernetes cluster is created and nodes are also available on the Kubernetes cluster. You can also see it from the user interface. If I just run search for GKE, Kubernetes engine, clusters, and we have this demo Kubernetes cluster, right? Demo autopilot cluster. The cluster is created and it's in the running state. That's all we need. Cool. So what are the next steps? The next step is to create Kubernetes manifests. Within the repository, if you go to K8 specification, you will already find the Kubernetes manifests that are created for vote microservice, results microservice, Redis, DB, and worker microservice as well. But Abhishek, what Kubernetes resources do I need to create? How do I understand? So you can derive that from the architecture diagram. If you look at this architecture diagram, let's try to see what are the microservices and which microservices are connected to other microservices and also internet. Voting microservice is connected to internet, so it needs a Kubernetes deployment, a Kubernetes service, and a Kubernetes ingress. Results microservice is also connected to internet, so we need a Kubernetes deployment, service, as well as ingress. If you look at worker microservice, this is, nobody is actually talking to this worker microservice, so we just need a deployment for it. Redis microservice, we need a deployment and service. DB, also we need a deployment as well as a service. That's why if we go to the folder here, so we will see for the worker microservice, there is only deployment. For the voting, results, Redis, and DB, there are deployment and service. Both for voting and result, Ingress service is missing. So I will create the Ingress resource for both of them when we plan to expose them. But Abhishek, here the architecture diagram says, Redis is talking to worker. This is actually not 100% true. A worker fetches the information from Redis. So this arrow should point to Redis, not towards the worker. So don't get confused with it. Cool. Okay. Now let's see how to run these files and what exactly is in these files. Let's go one by one. If we go through the outing microservice deployment, they're actually very simple. If you look at one microservice deployment file, you will understand all the other microservices deployment file. Outing microservice deployment file, you can technically copy it from documentation as well, because all that you have to change is these labels and selectors, right? So you have to change the label. You just have to change the number of replicas that you need. You just need to update what is the image of the container and on what port is the container running. All this information you can get from the developer as well. On what port is the container running locally? How many replicas are needed? Of course, you can take this decision as well. And labels and selectors, you can keep it according to your organization standard. For example, you can just keep the label as OAT, selector as OAT as well. Replicas, we just need one, at least for this use case. Container image, this container image is already created by Docker and it is pushed to Docker Hub. So we will use the same container image. In case you want to use your own container image, you can also do it. Instead of using Docker Compose, just run a Docker build command, build the Docker files for all the microservices and push them to your personal Docker account and use your personal Docker account image name. Cool. Now the same thing is for results microservice as well. If we go to results deployment.yaml, it is exact copy paste. Only thing that changes labels and selectors, number of replicas that you are interested in, and the container image. Worker is also the same. Exact copy paste, labels and selectors are changed, and the image name is changed. Redis deployment.yaml. Perfect. You can see the container image is Redis Alpine. Right? So this is a public image that is taken. Same is with DB as well. DB deployment.yaml. Everything is same. The image that is used is Postgres 15 Alpine. Cool. So let's run these manifests. kubectl apply -f K8 specification folder. Let me just go back. kubectl apply -f K8 specification. Okay. Now this manifest will be created on the Kubernetes cluster. You can ignore this warning. This is basically because on the Kubernetes pods that we are creating, we haven't mentioned the resources, requests and limits. So autopilot is actually complaining about it. Because if you mention the request limits as well as the request quota for the namespace as well, it becomes easy for the autopilot to decide the size of your Kubernetes cluster. Okay. kubectl get all. We have all the deployments running. We have all the services created as well. Cool. All the pods are also in the running state. So everything looks good for us. Now we can just get kubectl pods, or instead I'll just do kubectl get svc. So these are the services. This is the OAT service and this is the result service. I can just do kubectl port forward even without creating the Ingress. I'll just do kubectl port forward svc. Let me just take OAT 8080 colon 8080. Okay. But Abhishek, why are you port forwarding it? Like, you have the node IP address, which is a public IP. You have the port as well. Why can't you directly access 34.118.229.36 colon 8080? Now you cannot do that The reason is simple. You cannot expose firewall on a particular node port when you are creating Kubernetes cluster using GKE autopilot mode. So this is a drawback. You cannot use node port mode on custom ports that you have chosen. The reason is that when it comes to GKE autopilot mode, Kubernetes management and the node management is done by Google engine itself. So you don't have an option to go to a particular node and set up a firewall to expose port 8080. You can create Ingress, or if you are on your demo clusters, you can also use port forward option. So I'll use this port forward and let's see. Now the port forward is set up. Web preview, change port. Again, we will use 8080, change and preview. So you can see now the URL points to 8080 -cs followed by some random URL, cats and dogs, right? So we have casted our oath to cat. Again, I've casted my oath to cat. I'll just close this connection and I will do the same thing to result. Instead of 8080, I'll choose 8081 because results is hosted on 8081. Port forward. I port forward the information. Web preview, change port 8081, and we should see perfect. CADs got 100%. Now we can also conclude our demo here, but to understand better, let's see how these microservices can be hosted using Ingress. Like let's say you want to share this with your friend and you want to get a real opinion poll on something like I told, Docker versus Kubernetes or X singer versus Y singer. If you want to create your own voting application, so we can also do that. We will use Ingress. So how do we do this? Coming to the Ingress, we have to create the Ingress file. So I'll just call it as port-ingress.yaml. I've already pasted the Ingress file in the Day-14 folder. So if you just scroll down, yep. So you will find this Ingress. So this is the one. I'll explain you what exactly is part of the Ingress file. So this is the API group. You can't change this. This always have to be the same. Kind Ingress, again, this has to be the same. Metadata, you can put anything in it. Spec Ingress class name Nginx. So what are we doing here? We are using Nginx Ingress controller. A lot of people get confused. What is Ingress? What is Ingress controller? Very, very simple. If you want to expose any application, as a DevOps engineer, you will do two steps. Number one, for the service, you will create an Ingress file. And this Ingress file is read by Ingress controller. And Ingress controller reads the Ingress configuration and it creates a load balancer. This load balancer is used by the external users, right? So your job is to create an Ingress controller. This is one-time activity for the entire cluster. And you have to define Ingress for every service that you want to expose, right? So for the Ingress resource, you define Ingress class name. But Abhishek, why do we define Ingress class name? In some rare cases, your company might use two different Ingress controllers. Now, when your company wants to go with two Ingress controllers, how do you define which Ingress controller has to watch the Ingress resource? So that's why Kubernetes provides this option of Ingress class name. Now, this Ingress resource is watched by Nginx Ingress controller. Or you can also say it other way. Nginx Ingress controller only watch the Ingress resources with this particular Ingress class name : Nginx label. In the rules, I'm just using a Ingress resource without any host. So on the path slash forward the request to outing microservice, which is listening on port 8080. That's it. Very simple. Let's save this. Right now, I will not create the Ingress resource because before creating the Ingress resource, I'll first create Nginx Ingress controller. I'll create a namespace called Ingress Nginx. Okay. In the next step, I will use the Helm chart to create this Nginx Ingress controller. Okay. It's almost created. We can also verify. I'll copy this namespace. I'll wait for the command to be done. And then I'll run kubectl get pods ingress nginx to see the ingress controller is in the running state or not. Okay. Some admission controllers are set up. It again complains that we haven't mentioned CPU resource for the containers. For autopilot, it is actually very important to mention the CPU resources so that GKE understands what should be the size of your cluster. Should it keep 2 nodes as default? Should it keep 3 nodes as default? It understands all of that using the CPU requests and limits. Okay, it's almost done. Cool. So we have Ingress controller ready. kubectl get pods -n Ingress Nginx. So we can see it in the running state. Now, when I create the Ingress, this Ingress controller will read the Ingress configuration. Right? This will read the Ingress configuration. So in the Ingress configuration, we said anything that comes or any request that comes to /path should forward or that request should go to outing microservice. That is exactly what Ingress controller does. It creates a load balancer for us, and in the load balancer, it defines that target groups. Right? So that load balancer understands, okay, if the request comes to me on /path, I will just forward to my target group, which is the out microservice. Okay, so kubectl apply -f out -ingress.yaml. It's created. Immediately, if you try to see kubectl get ingress, you will not notice, right? Address is empty. If we go to the pods again, this pod, this is the ingress controller pod. I'll quickly show you. If I do kubectl logs on this pod -n ingress nginx, you will see it started reading out ingress. I'll show you. See here. So it started reading the out ingress and it said configuration changes detected, backend reload required, backend successfully reloaded. So it understood. Now if I do kubectl get ingress, you will see the IP address. And what is this IP address? This is the IP address of this load balancer. Right? Now ingress controller configured a load balancer for us, and this load balancer has the target group, which is the out service. I'll confirm this with you. If I just do the URL followed by /, you will see the outing microservice. Perfect. Let's cast a out to dogs this time. Okay, I casted the out to dog, and I will run the results microservice through the node port. Okay, it is running. I'll take a web preview. Preview on port 8081. Okay, outing microservice is running through Ingress. I casted my out to dogs. This is running. Which one is this? My bad. So this is running on node port on the web preview. You can see one out is casted for cats and one out is casted for dogs. We got two outs here because one I casted from the Kubernetes cluster and one I casted from the browser. That's why you can see two outs. One for the cats, which I casted before, and other is for the dogs, which I casted right now. If I change this O to cats, right? And if I refresh this page, you will see both of the votes are casted to cats. Perfect. So this is how you run microservice architectured application on a Kubernetes cluster. Now, at any point of this video, if you felt you could not understand some of the Kubernetes concepts, probably it's because you are new to Kubernetes. I have an end-to-end Kubernetes playlist, almost 40 videos in the end-to-end Kubernetes playlist. Also, I have a basic Kubernetes in 7 hours video. If you follow those videos, you can understand the basics of Kubernetes and, you know, probably if required, go through that playlist once and then come back to this project and complete the project. I hope you enjoyed this tutorial. The most important part here is that we have used GKE autopilot mode and the Kubernetes management has become simple. We did not create the nodes. We are in fact not bothered about nodes. Right now, if I do kubectl get nodes, from one node earlier, we have 2 Kubernetes nodes. As we keep deploying more and more pods, this can go up to 3, this can go up to 10, this can go up to n number of Kubernetes pods. Sorry, Kubernetes nodes. Finally, let's delete the cluster so that we will not get any charges incurred. Delete. What was the name of the cluster? I guess demo autopilot cluster. Let me just confirm. Yeah, demo autopilot cluster, gcloud, container, clusters, delete, demo autopilot cluster, region, quiet. Make sure you do it. If you do it, probably this entire demo would charge you $1 or $2. But if you forget to delete this, then if you keep it for a month, if you just forget it and keep it for a couple of months, you will get a huge billing from Google Cloud. So complete this video by deleting the cluster. Thank you so much for watching today's video. See you all in the next one. Take care. Bye-bye.